Right now, as you are watching this, roughly 90,000 Americans are asleep inside a hazard zone that the United States Geological Survey has already mapped, already modeled, and already timed to the minute. Mount Rainier produced the largest earthquake swarm ever recorded at the volcano, more than 1,350 located earthquakes, plus thousands more too small to even locate. At its peak, the mountain was generating about 40 earthquakes an hour. USGS research geophysicist Alex Yezi described it as the most significant event since monitoring equipment was installed on the mountain. In the Cascades Volcano Observatory weekly update issued on Friday, August 21, 2026, small earthquakes were again being detected beneath both Mount Rainier and Mount St. Helens. And the most recent major Lahar to come off that mountain, the one that built the ground the town of Orting sits on today, happened with no eruption at all. This is not a news cycle scare story. There is a genuine, quantified, federally documented threat attached to this specific mountain, and almost everything the internet says about it is aimed at the wrong hazard. So today we are going to break down exactly what the mountain did, what the alert level actually means, why Rainier is called the most dangerous volcano in the country, and what the realistic worst case actually looks like for the people living downstream. No guessing, no dramatizing, just the facts, the science, and the real stakes. Drop a comment right now and tell me this. Have you ever lived in the shadow of a volcano or inside a mapped hazard zone of any kind? Floodplain, fault line, hurricane coast, wildfire interface? Tell me where, and tell me whether you actually knew you were in it before somebody told you. Thousands of you watching this are in Washington, Oregon, California, and Alaska, and I want to know how many of you have ever seen your own zone mapped. If you want to be the first to know every time something significant moves underneath this continent, subscribe right now. It is completely free. A thumbs up helps enormously. Let us go for 5,000 likes so the algorithm pushes this to the people who actually live downstream. Let us start with what happened precisely. At 1:29 in the morning, Pacific Daylight Time on July 8th, an earthquake swarm began beneath the summit of Mount Rainier. A swarm is a cluster of earthquakes occurring in the same small area in rapid succession without the classic pattern of one large main shock followed by decaying aftershocks. Within hours, the Pacific Northwest Seismic Network was recording about 40 events per hour. By the time the sequence was fully cataloged, the Cascades Volcano Observatory had located more than 1,350 earthquakes with thousands of additional events too small to pin down. The average depth was about 2.8 miles, roughly 4.5 kilometers, beneath the summit. The largest single earthquake in the entire sequence was a magnitude 2.42 on July 11th. Now let me explain why those two numbers together, 1,350 events, maximum magnitude 2.4 torrs, matter more than the headline does. The magnitude scale is logarithmic. Each whole step up represents roughly 32 times more energy released. A magnitude 2.4 is not a small earthquake in the way a light drizzle is a small storm. It is a different order of event entirely. Nobody standing on the mountain felt any of them. The USGS stated explicitly that the shaking was too weak to trigger rockfall or glacier movement. And here is the part that gets lost. The total energy released by all 1,300 of those earthquakes combined is still vastly less than a single moderate magnitude 5. For context, Mount Rainier normally produces about 9 to 10 located earthquakes per month and experiences a swarm once or twice a year. The previous large swarm, in 2009, produced around 120 earthquakes with a maximum magnitude of 2.5 and lasted 3 days. So the 2025 sequence genuinely was a record in total events, event rate, and energy release. It was also entirely undetectable to any human being standing directly on top of it. The volcano alert level was green. The aviation color code was green. Neither changed at any point during the swarm. And that was not a bureaucratic default. It was a conclusion supported by direct measurement. A USGS gas team working with the National Park Service flew a helicopter over the summit and took measurements at the fumaroles, the small steam vents in the east and west summit craters. They detected water vapor and carbon dioxide. They detected no sulfur dioxide and no hydrogen sulfide. That distinction is the entire scientific story, so let me make it plain. When fresh magma rises toward the surface, it releases sulfur gases, because sulfur comes out of solution as pressure drops on the way up. Water vapor and carbon dioxide alone are the signature of a hydrothermal system, groundwater circulating through hot, fractured rock above a magma body that is not moving. Combine that with the earthquake depths, which stayed shallow and did not migrate upward, and the interpretation is straightforward. This was water shifting through the volcano's shallow plumbing, pressurizing pre-existing fractures, not magma, not an eruption sequence. Yezi added one honest caveat that I think is the most important sentence anyone said all summer. Rainier is roughly 500,000 years old. We have been monitoring it with instruments for 40, maybe 50 years. Calling something the largest swarm ever recorded is a statement about our instruments, not about the mountain's history. So, if the swarm was not the danger, why is Mount Rainier described by the USGS itself as potentially the most dangerous volcano in the Cascade Range? The answer has nothing to do with lava. Mount Rainier stands 14,410 feet high and carries 25 glaciers, the largest concentration of glacial ice on any single peak in the contiguous United States. Its interior has been chemically cooked for millennia by acidic hydrothermal fluids, which convert hard volcanic rock into weak, clay-rich material. You have a very tall mountain, made partly of structurally compromised rock, wearing an enormous amount of ice and snow. When a large volume of that material lets go, it does not fall as a landslide and stop. It mixes with meltwater and becomes a lahar, a fast-moving slurry with the consistency of wet concrete, capable of carrying boulders and whole trees, that flows down river valleys, picks up more material as it goes, and buries everything in its path. The geologic record here is not speculative. It is layered in the ground under people's houses. About 5,600 years ago, a massive collapse of the volcano's northeast flank generated the Osceola Mudflow. Estimates put its volume near 4 cubic kilometers. It traveled more than 100 kilometers down the White River Valley all the way to Commencement Bay at Tacoma. It buried over 500 square kilometers of land in places under deposits tens of meters thick. It created the Enumclaw Plateau. If you live in Enumclaw, Buckley, Bonnie Lake, Sumner, or Auburn today, the ground beneath your foundation is that flow. Then, around the year 1500, roughly 5 centuries ago, the Electron Mudflow came down the Puyallup River Valley from the volcano's west flank. It carried trees 3 meters in diameter and buried them under debris. The flat valley floor that the city of Orting is built on is the surface of that mudflow. And here is the fact that reframes this entire subject. USGS scientists have found no evidence of any eruption associated with the Electron Mudflow. It was a large landslide off the west flank. The mountain did not erupt. It simply gave way. That is why the hazard math is what it is. Recent studies show the west flank remains potentially vulnerable to a future large-scale collapse, which could send a lahar down the Puyallup, Mowich, Tahoma Creek, or Nisqually drainages. Mathematical models indicate that such a flow would reach residential areas inside the national park in about 5 minutes, and residential areas outside the park in 15 to 60 minutes. 5 minutes. Not 5 hours. A 2009 USGS study by Nathan Wood and Christopher Sollard mapped exactly who lives in an electron-scale inundation zone across King, Lewis, Pierce, and Thurston counties. The answer was 78,049 residents, 11% of them over 65, 39% in renter-occupied households. USGS communication materials now put the figure above 90,000 people in areas that could be affected by a future large lahar, and Pierce County has estimated that around 2.5 million people live in the broader region shaped by these deposits. Residents of Orting have been told in published hazard assessments that they face roughly a 1 in 7 chance of experiencing a lahar within their lifetime. Now let us do the comparison that actually decides whether those numbers become a death toll, because the world already ran this experiment once, and it ran it on a mountain almost identical to this one. On November 13, 1985, the Nevado del Ruiz volcano in Tolima, Colombia, erupted after 69 years of dormancy. It is a glacier-capped stratovolcano, 17,000 feet high. The eruption itself was moderate, not a Mount St. Helens, not a Pinatubo, but the heat melted the summit ice, and lahars formed and began racing down the river valleys. About 50 kilometers away sat the town of Armero, population roughly 25,000, built on the deposits of an 1845 lahar from the same volcano that had killed more than 1,000 people. The warnings existed. Volcanological teams had detected activity months earlier and had urged evacuation. Colombia's National Bureau of Geology and Mines had warned that even a moderate eruption would carry a high probability of dangerous lahars. A hazard map circulated in October 1985, 1 month before, identified Armero as high risk. It was criticized at the time for being too alarming. The first eruption came at 3 in the afternoon on November 13th. When seismic activity settled shortly afterward, authorities decided against evacuation. The mayor publicly reassured residents that there was no immediate danger. A storm that night masked the sound of the mountain. The main eruption came at 9 in the evening. The lahars arrived hours later, in the dark, while most of the town was indoors. More than 23,000 people died. In Armero itself, roughly 20,000 of about 25,000 residents were killed. 50 schools and 2 hospitals were destroyed. Every single piece of scientific information required to prevent that was in the hands of officials before it happened. Now look at the Puyallup Valley today. The Mount Rainier Volcano Lahar Warning System was developed by the USGS in 1998 and is operated by Pierce County Emergency Management. It uses acoustic flow monitors, instruments that detect the specific ground vibration signature a moving Lahar produces, tied to all hazard alert broadcast sirens in the valley communities. In 2022, the National Park Service approved 9 additional Lahar detection stations on the southwest side of the mountain, specifically to buy time for Ashford, Orting, and Puyallup. School children in Orting practice walking to high ground as a routine drill. The hazard zones are published, mapped, and public. Same volcano type, same glacier cap, same Lahar physics, same population sitting on old mudflow deposits. The difference is not geology. The difference is that one community was told, drilled, instrumented, and mapped, and the other was told it was fine. And I want to be precise about what that system can and cannot do because it is easy to oversell. A detection system does not predict, it detects. The sirens sound when a Lahar is already moving. Against the modeled timeline, 5 minutes to the nearest residential areas inside the park, 15 to 60 minutes to communities outside it, while einsteins the entire value of the network is measured in minutes of head start. That is enough time to walk uphill. It is not enough time to drive out of a valley in traffic, which is exactly why the drills exist and why the instruction downstream is to go up, not out. It also means the failure mode is not technological. It is behavioral. Armero did not lack information, it lacked belief. So when you see a headline saying America's most dangerous volcano is shaking like never before, the natural instinct is to assume an eruption is building. Is Mount Rainier waking up? The honest scientific answer, based on everything measured, is no. But the picture is more nuanced than a simple no. Volcanic seismicity waxes and wanes constantly. Rainier averages 9 to 10 located earthquakes a month and has swarms once or twice a year. Only Mount St. Helens produces more earthquakes in the Cascade Range. As of the Cascades Volcano Observatory, weekly update on August 21st, 2026, every volcano in the Cascade Range of Washington and Oregon, Baker, Glacier Peak, Rainier, St. Helens, Adams, Hood, Jefferson, Three Sisters, Newberry, and Crater Lake, sits at normal background activity levels, normal and green. What an actual pre-eruptive sequence looks like is different and specific. You would expect earthquake hypocenters to migrate upward over time as magma ascends. You would expect harmonic tremor, a continuous rhythmic signal rather than discrete pops. You would expect measurable ground deformation as the edifice inflates, and you would expect sulfur dioxide in the gas emissions. In 2025, 3 of those 4 were absent, and the 4th was explicitly measured and found missing. The thing that has genuinely changed is not the volcano. Rainier last erupted in a small way in 1894 to 1895 when summit explosions were reported from Seattle and Tacoma. It has been building itself through untold eruptions for 500,000 years, and it will keep doing that. What changed is that in the last 120 years, we filled its valleys with towns. Let us be direct about the practical message here because information without action is just anxiety. Armero died because a mapped, published, well-understood hazard was treated as a rumor. Orting is safer than Armero, not because the mountain is kinder, but because Pierce County spent decades installing instruments and rehearsing children. Rainier's record swarm was measured, explained by gas chemistry within weeks, and correctly kept at green. Here is what you can control, and most of it takes one afternoon. Find out whether you are in a mapped hazard zone. Pierce County and the Washington Emergency Management Division publish Lahar inundation maps by address. Learn the boundary of your zone and where the nearest high ground is on foot from your house, your workplace, and your child's school. If you are downstream of Rainier, the rule is go up, not out. Walking uphill beats driving through a valley in gridlock. Learn what the Ahab siren actually sounds like and treat it as an order rather than a test. Keep a go bag with water, medication, sturdy shoes, and a torch by the door, not in the loft. Agree a single out-of-area contact everyone in the family texts. Sign up for the USGS Volcano Notification Service so you get alert-level changes directly from the observatory rather than from an aggregator headline. If you are elsewhere in the Cascades, the same logic applies to your valley, your mountain, your river. And if a scientific agency ever tells you a hazard map is being criticized as too alarming, remember that is the exact phrase used about Armero 1 month before 23,000 people died. Final thought. Mount Rainier has been assembling itself for 500,000 years. It has collapsed before, it has erupted before, and it will do both again on a timescale that has nothing to do with human news cycles. We cannot prevent a Lahar. We cannot reliably predict the day a weakened flank finally lets go. What we can do, what Pierce County has already demonstrated is achievable, is decide in advance how many minutes of warning we are willing to pay for, and whether we will actually move when we get them. Armero showed what happens when accurate science meets institutional reassurance. The Puyallup Valley is showing what happens when a community accepts that the ground it lives on was delivered by the mountain it can see from its front porch. The largest earthquake swarm ever recorded at Rainier turned out to be water moving through rock. That is genuinely good news. But it also produced something more valuable than the alarm it caused. It proved the monitoring network works, that the science can be resolved within weeks, and that the alert level can be held steady while the internet panics. The mountain is not the problem. The mountain is the same as it has always been. The open question is whether 90,000 people know which way is uphill. We will keep tracking every alert level change as it happens. Subscribe so you do not miss it, and leave that comment below. Have you ever lived inside a mapped hazard zone, and did you know it before somebody told you? Because these are not just geological events. They are human decisions.